experience and has as a background an applied mathematics degree from her. So now I'm passing the baton to Andy Singh.
Hello. I can talk loud anyway. So the subject is what Agile can learn from open source. It's a special request from Ron, which is, he also asked me not to say anything really outlandish about how horrible traditional Scrum is, because a lot of people here go for that. I can let loose, I'm off the leash. I should talk about why I got into this. So I did start Assembler to take some of these open source ideas and bring them over into commercial software development. And the reason that I was interested in that is because open source teams accomplish a lot, and they have some specific things that they can teach us about. One is distributed teams. They also experiment with a lot of different development processes, tools, and workflow in huge volumes. There's millions of people doing this. Open source teams can be very scalable. There are projects that have thousands of contributors, which most commercial developers would not even attempt. And they've been doing it for a while. So some of these processes are pretty well established, and actually a lot older than the sort of the prescriptive processes of Agile. So corporate Agile teams have some specific challenges that are not addressed often in the traditional specified Agile methodology. One is that their teams are distributed. Most Agile methodologies say you should have co-located teams. They use different contractors, outsourcers, all sorts of different people are involved in these projects, and that doesn't really fit under the umbrella of a Scrum team that's a tightly managed group of people. And they work on big projects that fit outside of the range of these sort of self-managing Agile teams. And open source, of course, is effective with totally distributed teams and with some of these big projects. So what we'll do is we'll look at what does Agile do, what does open source do, and then try to get a blend of the two practices that might represent Agile learning from open source. Does that sound cool? So here's my first thing. I haven't done this, so I don't know whether it's just going to be boring to just read through the list, but I'm going to try it once and see if it's boring, or see if I should just skip over that and go to the learning. But when I think about Agile teams, and this is true for most kinds of Agile teams, but especially true for Scrum, which is the dominant methodology, it's small teams. If you have one person, you don't need a methodology. If you have more than 10 or so, you sort of have to break your team apart. It no longer works as a self-managing unit. So you're talking about 5 to 10 people, and you cluster them together. So you can sort of create these clusters of teams to work on big releases, and they coordinate between themselves. And if you have distributed teams, it's often outsourcing, where it's not like your team is dispersed, it's just there's another team in a different location. Whereas with open source, it's always viewed as a single global team. You have people in multiple locations, that doesn't make them any more or less of a team. And there's no specific size. Obviously, a lot of projects are done with one person, but you can have lots of contributors. You can have this penumbra of contributors. We'll talk about how they're organized. And people aren't. We'll talk about this. People aren't managed. They work for many different organizations. They're always distributed. It's really very difficult to find an open source project where team members aren't dispersed in some way, and they never meet. I always think it's funny when Agile people say, oh, we have to get together, we have to create some teamwork, we have to get to know each other, we have to travel, we have to chat every day. Well, you don't. Actually, you don't. You can make really great software and never do any of those things. And here's sort of one of the most interesting features of this comparison. The goal for corporate Agile teams is to have self-managed teams that are very pure consensus-oriented, and it's sort of very socialist, right? Whereas the goal for open source is just to produce code, and this sort of very cooperative socialist process is really very hierarchical. You send code to somebody, And it's very command and control, and he decides if he wants it and wants to send it on to the next guy, and so on. So it's sort of a very interesting difference between the way you would normally think about the two kinds of roles, corporate and managed versus this sort of cooperative thing that's really very hierarchical. But in the open source world, the one thing that's not hierarchical is command and control. People are actually not managed in most cases. So that leaves open the question of, well, how do we manage these projects?
So the other thing is that people opt in for open source, while in Agile they are brought together.
Yeah, it's a lot more work. You do a lot more work to bring people together in corporate Agile teams.
Exactly. So the open source is opt in. So obviously there is a different, you don't get to opt into projects or opt out of projects when you're in a corporate environment.
Yeah, you do, but it's a much bigger deal.
I know you're doing differences, but there are also similarities.
Yes.
Common values. And that's, for example, this co-ownership similarity, the idea of global ownership, not individual ownership. It works different. The structure is different. People saying, as you mentioned, people would decide whether or not to use it. Okay, and so it's like a consensus building of the code, where people are looking at it one at a time versus people are looking at it two at a time, or more than that. But the basic idea is that leave your ego at the door when it comes to how good the code is.
That's true, and it's a best practice, I think, in both parts of these teams to discuss the code and the work separately from the person. It actually may be easier in an open source world. You see people flaming each other because they're doing it over the internet. It's a lot easier, but it's easier to just say, okay, I like this code or not, and not get into a political battle. So that's a good learning you could take away.
The major difference here is that they don't have, commercial organization. Right? It's a labor of love.
Well, actually, I have to object to that because a lot of the most important open source that you use, like the Apache server, Subversion is a project I'm involved in now. Most of the people on it are paid to work on it for commercial reasons, but they're paid by many different organizations, so there's no one boss. So you still have this problem that although you're working together on a business and a commercial project, you're not managed in the normal way.
Will you be talking more about the hierarchy?
Briefly, I'll get to it when I talk about who makes the decisions in these teams.
How does it managing users?
We'll get to that too.
I guess it seems like Apache, that's more like a common thing, but if one's making a proprietary or a business product and people work for many organizations, who pays them? How do they decide how much? And how is it decided who gets the product?
Well, in open source, that's an easy decision because everyone gets the product. It's freely licensed to everybody that works on it, and even to you, worthless bastards who never worked on it, right? Or me. And
So who pays them?
but the question is, who pays for this? And there are many reasons why companies pay people. Essentially, the contributions they pay their employees to work on these projects, so they hire people and pay them a salary out of these projects. A good example is IBM. They run a lot of their computers on Linux. They contribute a lot of money to something called the Linux Foundation, which manages Linux releases, and also they contribute developers and code out of their own tools, out of their own work. And tools. So, and there's obviously a reason for that. It saves them a lot of money on sort of building, promoting, and integrating an operating system that does what Linux does. So the thing that I took away from this when I first looked at it was that people are working in distributed teams. And I might come back to this if we have more time. I have a standard shtick that I do about distributed teams. So that sort of blends what open source teams do and what corporate Agile teams do. So for instance, I think you can run a normal Scrum process or whatever with a distributed team if you do these things. Share a daily or continuous build so that everybody on the team can see what's going on. Release on a fixed schedule, that's really the core of Agile. Write everything down in tickets so that your team members can see what you're talking about without calling you up or going to visit you. Do a daily chat and maybe even a stand-up report. We have a tool like that in Assembler, just a little form. What am I going to do today? Do I have any obstacles? Key thing to remember, if you just don't remember anything else about distributed teams, do the chat at the same time every day. Never move it around. People will adapt to it. I hear a lot of people coming in and say, oh, you should move it around to be inconvenient for different people at different times. Don't do that. Team activity stream, which is sort of like a Facebook news feed. You should have a tool that shows you what everybody's working on. That way you feel like you can work together as a team. And this is a very important tool for open source teams as they work together. And finally, recruiting good people. And we'll see later on that that's a very important component of success in every endeavor, including open source. Easier, obviously, if you have a global pool to draw from. And more importantly is what you don't do, because that's what increases your productivity. Don't travel, right? These guys never travel. Architect in advance, that's sort of an Agile principle. We'll skip over that. Project managers, open source projects are very flat. It's typically 15 or 20 contributors to what they call a maintainer, sometimes even more. And they're all programmers. There's no project managers. So a lot of statistical evidence showing that project managers, for whatever reason, are correlated with lack of scaling. Conference calls, people hate conference calls. These guys never do meetings where they're sort of not coding and having to pay attention. Interviewing, we'll talk about that, how you can do trials instead of interviews. And finally, estimating. We'll also get to that, why they don't estimate.
If you don't architect in advance, when do you do the architecting?
Well, this is a big controversy. Obviously, you need some architecture. The question is how much to invest in architecture that you're not going to use in the next release, whether you should architect as late as possible. And the argument against doing extra architecture or structure is that a lot of the time you don't end up needing it. Either, if you think about it, a lot of time your project gets canceled, changed, or you end up not needing that. And it's sort of 100% gain if you didn't do it in any of those cases.
So that's whether to architect. What about when to do it?
Well, I believe that planning and design are important, but you can fit those in incrementally. And a good example is Linux. Linux started as a summer project for somebody to build a little Linux shell, and they actually built it up incrementally to what it is now, if you can believe that.
What is the
As late as possible. So this, you've seen before, it's from Mountain Goat Software, came off the internet, but this is the basic Agile cycle. The basic idea is you grab off some stuff to do and you release, or you have potentially shippable, that's a sort of a fudge on a release, on a fixed time cycle. That's the basic thing that makes Agile work. And that reduces your risks, because you never have sort of unintegrated, unseen stuff that you don't know when it's actually going to work. So, Agile, let's talk about how the project is run. Multiple small teams with meetings, like scrums, to resolve dependencies. They try to get consensus. Open source, screw that. They either take your code or they don't. You can see that all these things save a lot of time, right? Whatever you think of them. Agile, you release iterations on a fixed time cycle. It's really important. With open source, you release it when it's ready. You keep putting out release candidates, and when you get a good one, you have a release. But what you do on a fixed cycle is you publish the last stable or the daily build. Everybody can go and try it if they want to. This is something if you guys are old enough, I hate to say, if you remember Netscape used to do that, the Netscape beta, they sort of started that. It's a useful commercial process as well. Finally, something that's the same. They both work from a backlog of requests. Then something that's really, really different that I'm going to talk more about, which is with Agile, there's a lot of effort. I've always wondered about this, because I don't do it. Okay, there's a lot of effort to plan and estimate each iteration at the beginning of the iteration. So what did we see? Sprint backlog. You want the right sprint backlog. With open source, you really don't care. Okay? What you care about is at the end, when you're putting the release together, did you bring in the right code, the code that works? And this, again, is another major efficiency that I'm going to drill down on. Who asked about team leadership and hierarchy and stuff like this? So in Agile, we have this idea of roles of people who provide different kinds of leadership. A product owner who reports on user requests and sort of says what should be in the product. There's always, I love this, the fact that in the Agile methodology, there's never a role for the guy with the money. You ever see a slide where there's a guy who basically holds a sword over everybody else's head? But that's a really important role, who controls the budget. And typically, well, we'll talk about this, but typically, that's the sticking point in Agile projects. It's never a sticking point in open source projects because if you're IBM and you're contributing developers, you just pay the developer. You're paying for developer time. In Agile projects, you often see a role called a Scrum Master or something like that, or consultants. They would never do that in open source, okay? The person doesn't code, or if they're in that role, they're not coding, well, that's not useful. So you also see that in really well-functioning Agile teams, there's a lot of peer pressure, and that's what keeps everybody's performance and attention up. It's sort of designed to create that peer pressure. You also are really working off peer pressure and peer reward, and you're working for respect as much as for your employer in the open source community. But it's not. You get rewarded for those big visible contributions that you make, sort of episodically, and so there's kind of a different dynamic that it's pretty easy to get burned out this way because you can get faster and faster and go more releases. When do you stop? When do you stop? It's more episodic in the open source world, and it's very important who hires and fires in Agile teams. You were talking about that. You're literally hired to be on an Agile team as part of a business. In an open source world, it's not that important, right? If you contribute good code, you're in. If you don't, you're not.
Let me get that right. What you're saying is that, are you suggesting anyway that the open source model is just another option, or is it better than Agile according to you?
Well, each of these things evolved to fit a certain need, but if you're having trouble hiring and it's a long, painful process, you might want to consider some of the things that the open source guys do. It's a solution to a problem if you have the problem.
I have another follow-up question. Have you had the experience of running a well-functioning Agile or Scrum?
Well, I run a couple of different projects now in my company, and I wouldn't call what we do Scrum. I'll get to that later. So I have some particular criticisms of Scrum. But I would say that what we do is closer to Scrum than pure open source. And I'm going to talk about that. So for instance, it's very fixed on schedule. We work every day, we work every week, we release every 3 weeks, which is not true of most open source. Did that answer your question?
Not very much, but I will.
You have a benevolent dictator. Is that the one who acts like the product benevolent dictator?
Well, the benevolent dictator actually came from Linus Torvalds, who's the most successful of these guys.
Who decides the priorities? Well, the product owner you have there, the product owner reports and user requests, does more than that. Product owner also represents a prioritization. What's more important from a variety of different reasons. Who decides that on the open source? Is that
Well, it's much more of a negotiation. So you have users.
There's always a negotiation, even in Agile.
But you're actually talking directly to users in the open source case. The vast majority of the time as a developer.
When you have, let's say, take Apache, take some of the other things. You said there's 20 people who are involved in development. There are hundreds, if not thousands, of users. They are not all involved in that decision making. The decision making is.
They are not all involved, but the way that stuff bubbles to the top is there is one user, one real actual user who posts an issue and has an idea about what should be done. And if a developer becomes interested in that, it becomes a priority, and there's direct communication between those people. There's literally
You're missing
emails going
something
back and
there.
forth.
I think you're missing something there. I believe your benevolent dictator, if somebody says at IBM they want this feature added, it's gonna get added.
It probably will, but mechanically the way it gets added is because the guy that's assembling the release, that's the benevolent dictator. The guy that says, yeah, this is code we want. And that's where the dictatorship comes in, is that
So
he
that's
can
the
actually decide,
prioritization.
do I
That's
want
the
that code?
prioritization. So there is a product owner.
Yes,
But that's assembly together of the code, not that saying you guys.
well, there's a
this
leadership
code.
role that's very important. You can
think
call it a product owner, I guess.
I think it's overly stated there isn't. I think there is.
Okay.
Yeah, I see users submit requests and so on. I can see for an open source thing like Linux or Apache, the users can be assumed to be quote unquote savvy, and they're knowledgeable users. I'm thinking though in application software development, often the users are not savvy. They might not even know about computers, may not want to know about computers. And that's why the product owner often represents the users. So how does open source work if the users are not savvy about computers?
I don't think it works very well, because this really is the way that it works. A user explains the problem or comes up with a solution, but there are a lot of users out there, and some of them are very computer savvy. We're not talking about reaching every single user. And it's the whole idea that given enough eyeballs, all bugs are shallow, the Eric Raymond thing.
Yeah, I just want to throw out some stuff. Just so everybody knows, I'm involved in several different groups, and one of them is I'm on the board of the Boston Linux and Unix group. So I know a little about both sides of the air. Just to throw out a couple of things. The concept of benevolent dictator, a lot of projects don't have that kind of concept, and in fact, there's been a lot of pushback on that lately. But there is at least a group of people that are running the project. So for instance, I just selected a new wiki engine, and the wiki that I selected originally is an offshoot of a tweaking, and the reason that they did that offshoot, the branch, was because the guy who started it wanted to take it over and have total control over it. And there was pushback. Being open source, they just created a branch of the software and started their own thing. Also the pushback that's been happening on Oracle for taking over Java. So there's a lot of resistance to that. But whether there's a benevolent dictator or a group, there's generally a group that functions as the product owner and as management. But to answer your question, in open source, you'll find that the people that are contributing, hey, I like this feature, or hey, I got this bug, are the more knowledgeable users. The people that don't know what they're doing generally don't even get involved in the project. But once somebody submits something into the issue system, it often gets clarified. Like I've submitted issues for open source software, and they say, oh, well, you can do it this way and that way, and you get your answer that it's already implemented some slightly different way, or that's a good feature, but we need to combine it with this, or we need to integrate that feature first. So an issue can be a starting point of a discussion, not a task.
How does a company influence, like IBM, influence the direction that they want the open source product to go? And they obviously have a vested interest, right? I mean, they're paying you or the other developers. So how is it that they achieve the influence? Because as it says, and I know there are some smaller projects, some open source projects where, hey, I pick up something, I think this sounds like a nice thing I would like to have on my own instance of this app, so I code something in.
How do they get that into the release?
Well, IBM,
It's actually very easy. They pay you, okay?
They pay
So
you. They pay
if
you.
you want something in the release, you pay someone. You do it yourself, or you pay someone to do it. And if I do this myself, right? I'm fixing some things that I don't like, or you hire guys just to fix that.
But you have to be a contributor, right? They have to only hire guys that are legitimate contributors to the source, because otherwise, how do you guarantee that something's going to make it into the code stream
Well, you don't guarantee it, but if you produce something good, it's gonna get accepted. And if there's really a philosophical argument about it, you just fork and make your own version. In which case, it's even more expensive, because you have to maintain that, but those are all options. It's all just a matter of paying people to do it.
And the crux of my question is, how do you guarantee that you don't want to fork, obviously. You're not going to fork off of like a Linux or something like that to get your own flavor.
Well, I would if I had to.
That's actually what happens a lot.
It is what happens.
So for instance, Red Hat and SUSE, or the company that now owns SUSE, I forgot if it's Canonical or whatever. But the different companies, so for instance, Red Hat will produce something that's really cool that they want in their software, and they'll give it back to the people that are holding the benevolent dictators of the Linux kernel. And if it's something that they want to include, they'll include it. But they can say, no, I think that's evil, we don't want that. And they'll literally have to, when they want to do a new release, they'll patch in their version of it. Or, you know, if it's a big egregious thing like the case that I was talking about with the Wiki engine, they will create a fork. And I monitor the IRC chat of the group that's doing that development, and they have discussions about, well, we created this patch and we gave it back to 3D because we want to share our stuff, and they don't want that patch. And it's like, well, that's their problem.
In terms of potential lesson for my Agile teams, in that one of our big challenges is getting the disciplines to swarm, because we have typically a VA discipline, a coding discipline, a QA discipline, and trying to get them all to swarm is sometimes quite challenging. And I'm guessing, based on what I've seen here, what I've heard about the open source community, that there isn't a QA infrastructure. It's all about the coders. So
That's a good point.
So but on the other hand, people tend to point to the successful open source projects as having higher quality than a lot of commercial products. Whether that's true or not, that certainly is.
Well, if your developers were motivated enough, they would fix all bugs as soon as they were noticed, and if you had enough users, they would notice the bugs. So that's sort of the theory, and it does work at a big enough scale.
So you'll let the bugs out into the wild, and you let the wisdom of crowds crush them?
Well, you let your release candidates and your beta releases out. If you have enough users that want to participate, you're doing okay.
So there isn't a concept of trying to go right before you release it?
No, which is why the stabilization process for commercial and open source is different, and I'll maybe mention that too.
I've been involved with the Boost library, which is sort of a trial version for the future, and too specialized for the C++ STL. There's a lot of QA. There's a core set of developers that are familiar to anybody who reads the developer news group, but there is no dictator. But what there are a large number of people who push for community standards, which includes heavy testing. Everything that goes into the library. Now, this is a library, not an application.
Well, and one thing I'll mention is that open source guys, it's all about the code, right? You can do a lot of QA in code. You can write test suites, and that's a very common management tactic in any big project, but open source guys do it too. And so they turn that into code. I'm just going to clarify this benevolent dictator. There are many projects, and there's even software. We use it at Assembler. We embedded a piece of software called Garrett that allows you to vote on the code that's submitted. So you can have a group of people who are reviewing it. It's not all on one person's shoulders, which makes it a lot more scalable, deciding what code's in. But there's a very important difference here, which is corporate Agile projects manage people, and open source projects manage code. And there are reasons sometimes that you want to manage code. People are very squirrely.
The Agile process is to support a business making money. Open source, not the case. They can afford to take however long it takes to cook it completely, get all the bugs out of it before they're happy releasing it. In Agile or a corporate situation, it's got to be released next week. There's a pressure to get something done that's gonna drive the need for the kind of testing or all the bugs don't get fixed. And to David's point about, open source projects having the perception of higher quality, well, they can afford to wait until it's cooked enough to wring out all the bugs before they let it out.
Well, that's a good
That's
point.
my
I mean,
perception of what
if
you're
you're
saying.
interested in speed, you're gonna take a hit on quality. And a lot of corporate agile projects will decide that, yes, I'm gonna run a shorter cycle and I'm gonna accept a much bigger QA challenge. That's true.
But open source, there's a lot of companies making money on open source. And remember, as you said, most of the code that's being put into the open source, those people are actually paid.
Yeah, and there are the same kinds of pressures to release in open source. I know because I've been through it a few times. So, but I think the idea that if you're on a fixed cycle, your challenges are going to be greater. That's very true.
So one point that you're not mentioning at all right now is refactoring. Especially if you're talking about managing code being important and architecting as late as possible. Refactoring has an important role in typical agile development. How's that dealt with in the open source world?
If it's enough pain, somebody will refactor it. And that's the exact same principle that's applied in the corporate world too. So I don't think it's
If they're
that
all
different.
focusing on visible contributions, to me it will seem like there's going to end up being these projects are just going to gain more and more craft, more and more technical depth.
That's not true. If you're talking to programmers, remember we're talking about people who speak in code. That's what open source is about. The actual code is a visible contribution. I'm going to keep going because actually it's a lot of material if you guys don't mind. So I'm just going to get into some of the learnings. You guys take away different learnings than I did. But one of the big learnings, this is a big sticking point for me with Agile, that sticking point with everybody, which is, I wrote this all out, maybe that was too much. But when you are working on a corporate Agile project, your scope has to be variable. The only way that you can say, look, I'll work on something, I'll change what I'm going to do so I'm actually making the product better, is to have variable scope. And the only way you're going to guarantee that, boom, you're going to release every month is to have some variable scope. The problem is that doesn't fit with the way people do budgeting often. They say, hey, I put in $1 million, I want to get this list of things. And it's very destructive to Agile. Those same companies don't apply the same principle to open source. If they're contributing to open source, they'll pay someone, they know the guy's good, woman, they know that person's good, and they know that they're going to get their money's worth. So budgeting for developer time and not for deliverables is a really important lesson for both of these things if you really want to speed up your projects. If you get too tied up in budgeting, you're going to slow everything down because there's a lot of negotiation that has to take place that delays the start of the project and also delays the delivery. So,
Inherent in what you're so you're kind of saying what you have to do up front is negotiate expectations that scope is going to be variable.
well, the way Agile teams do it is they negotiate expectations by releasing frequently. They establish credibility, and that's really important. So don't miss your schedules. That's something that people learn. Another thing that I learned from this is that out of all those roles, you can sort of get rid of them if you have someone who manages the code and answers questions from programmers. We call this a technical lead. It's a developer managed process. And we believe that you can take good developers and teach them some simple things and get really good results with technical leads. We also believe that this is something you absolutely need if you have distributed teams, because they do tend to communicate by exchanging deliverables. You have to be able to look at things like code and talk about that to lead these teams. And finally, the idea of managing code, but not people. There's a lot of reasons you might want to do this, especially on big projects. Think about how much harder it is to coordinate 1,000 people than 5. In fact, it's almost impossible. The statistics on 1,000-person commercial software projects are that more than half fail, and they're always triple the budget. There's a lot of studies on that. How do you do that? In the open source world, there's been a tremendous amount of innovation in code contribution processes. How do you take code and move it around and decide whether you want it and merge it and so on, and code review it? These are all things that commercial projects can benefit from, and makes your project more scalable. So those are the things that I got out of that. that are a little different from what you guys got. Another comparison I'll make is tools and libraries. So in a commercial environment, or non-open source, because open source is often commercial, but in a non-open source environment, you can have these specialized developer builds where this guy has this expensive tool and he works with this library, and it's really not shared with anybody else. They just get the output. You can have that. In open source, you never do. It really doesn't work if you do that. Every developer has access to all the code and all the tools, and they can do a complete build of the entire system. And that's why systems like, there's a lot of advantages that come from that, and that's why systems like Linux are so picky about making sure that that's true, that you can get all the components of the Linux system and all the tools. And there's some other things that come out of that that are sort of, if you have thousands potentially of contributors and they come in and out and sort of there's a number of contributors, you can't have anything that's licensed by the seat. That would be completely impractical. And for the same reason, you almost never use commercial libraries. It's just too many instances. And the same principles actually apply to cloud computing. Companies that do cloud computing, my company has cloud computing. It's not at the scale of Facebook or Google or Amazon, but none of these companies use commercial software because they just have an infinite number of servers, and the licensing gets really very complicated. Something to think about. But the lesson that I take from this is that if you share, you can scale. You can spread your problems out with a much broader group of contributors. And that means that you need to develop and maintain the developer setup documentation. You make sure that that's good, that actually the way that developers get started is good so they can all get started. And that they can all run complete builds. And I think somewhere in here I talk about do-it-yourself as a solution to dependency problems. So we'll talk about how important that is for scaling. It's really something to think about if you're running into some of these scaling problems. So different approaches to scaling. Agile, divide into small teams. With open source, you have a lot of individual contributors. They may not be parts of teams. They may be companies. There's really no natural size. It's very fractal. In Agile, in corporate Agile projects, it's typically very important to manage your dependencies. Oh, I'm waiting for this from you. I'm not going to be able to, literally won't be able to do the release unless you give it to me. And the same thing is true of open source projects, but there's an escape valve that's more often used, which is you can fix it yourself. So you start to see why this concept of total sharing everything in the project becomes really important because actually there's a lot of these dependencies in any project, and that is, I believe, the major source of delays. We're going to talk about that in a minute. We also talked about the difference in organizational philosophy, coordination, peer group consensus versus essentially hierarchy. There is a person who can decide whether he wants the code. Because you're working together more closely on a tighter time cycle, you're usually doing continuous integration in a corporate Agile project if it's well run. You're going to have regular daily builds and alpha release cycles, but with the open source projects, but you can have big features that are just held out. Somebody's working on them, held out until they're ready. They're not going to go into that continuous integration.
One of the promises of Scrum is that we get better results by having smaller features, smaller releases, and so on. And we do that by consensus, by having to make it work, by improving the backlog and all that. With open source, I can't depend on you. I don't know what you're going to do. I can only essentially work on a small piece. And so it forces people at a certain level to automatically do the small pieces and get rid of the dependencies. I mean,
or take more time. There are some very big chunks that are done, but they're done on the schedule that's appropriate for the chunk. Which, if you think about it, is a big problem with corporate Agile, right? You have this cycle, it's not appropriate for some of the big things that you want to do.
I think the one point I'd like to make is that in traditional business environment, we don't get to, you get the team you get, whereas with open source, it's self-selected. I mean, for example, everybody who's here chose to come here. So, when I hire, I tend to hire from the people who come to these kind of meetings, but I don't have to ask, oh, are you dedicated to continuing education? I know that. If you're one of the people doing open source for free, I know you're interested. You're not just doing it for the paycheck. So it's a self-selecting
That's true, although there are people doing it for the paycheck. I have a different theory on why the teams work, which I will get to, which is that they're actually extremely selective. But just my remaining issue on the scaling slide is planning projects is hard, right? Project management is a really hard methodology that rarely works. And it limits your skill, but it gets harder, exponentially harder as you have more people involved. So that's an issue. What have I learned from this? First thing, sharing allows you to fix it yourself. And we know this can work because some of these projects are big and complicated, some open source projects that are not centrally managed. And what that indicates to me is that the mythical man-month hypothesis that well, let me just back up. How many people here have read The Mythical Man-Month? I find almost everybody has. Great, everybody's read it. The basic problem is, it's sort of the fundamental problem of software, which is as you make your projects bigger, they become less productive and slower, and it becomes harder and harder to accelerate your deliveries. And the guy that wrote this book, it was 40 years ago now, described this problem. It's the same problem in any big project. And his analysis was, well, gee, if you have 100 people, you have 10,000 different communication paths. It's the n squared problem, as compared with 2 people that just has 1 communication path. So you're creating a lot of noise. And his solution, some of his proposed solutions were to break people down essentially hierarchically into sort of tool building groups. So now you get rid of a lot of communication. You're communicating in your group. It's the Scrum solution, right? It's the small team, and then they get together and they feed each other. And I think this is just complete crap. Okay, it's just it's a very bad analysis. There's a mathematical analysis that's a better analysis, which is to say that if you have 100 people working together, at any given time, 50 of them are going to be waiting for something from the other person. As your network gets bigger, you have more delays due to dependencies. More people are waiting for something, and that's the problem that you need to manage. And this fix it yourself actually gives you a good way to manage it, and the idea that you've shared everything, having more communication actually gives you a chance to see those dependencies and break them or fix them.
If I understand your description of this fix it yourself, what you're allowing for is duplication of effort, which is fine for the efficiency of open source projects to get something done because you just throw resources at it and you limit the communication. So you don't have the mythical man-month problem that we're talking about because the communication paths aren't 1,000 factorial. They're still in small communication paths. What you can't do, because the underlying problem is totally different. In the open source, you're talking about projects where the developers are a superset or a subset of the user.
So what's the difference between the problem?
With the business, you're talking about the developers and QA are not the target audience of the software in most cases. You don't have accountants building an accounting system. You need somebody to manage the product backlog because developers don't know what ought to be in there.
Well, yeah, and yet there are open source accounting systems. I deny your entire premise.
That may be, but in general, that is a difference between the two systems.
And so you're saying that less communication is required because they don't have to communicate with users?
No, I'm saying that in the business environment where Agile makes sense, you cannot afford to have a duplication of effort. You have to have an efficiency.
Again, you're like so far off the mark. If you have 100 people that are 10% as productive as each of a 10-person team, which is a very typical large project situation, you're already duplicating effort like 9 times for every person that's working. If you can duplicate effort just twice, oh, you were working on it, but I'm going to fix it, your maximum productivity slowdown is a factor of 2, which is far less than the factors of productivity slowdown you actually see in big projects. Far less. So I love duplication of effort if it gets stuff done. because it's 2, right? The most you can do is spend twice as much. That's the worst you can do. And that's the best you can possibly do in a big project.
That's quite that's crap.
All right, what do you think the productivity slowdown is?
You can't afford to plan to have wasted effort.
I
I'm
often
not
do
saying-
that. I often have 2 people work on 2 different implementations of the same thing. I know I'm going to get a result that way. And you know what? That was how the U.S. won World War II. They just, you want to build an atomic bomb? Here's 3 ways to do it. We're going to fund all 3.
But they planned because nobody was trying to make a profit on the bomb.
Oh, but
They planned
you
to
could
spend
make a
money.
really good profit if time is money on that.
The
tax.
vax and the thing in general.
If they plan that is cost effective to spend that kind of money, then yes, you throw all the resources at it. But that's a decision that the business has to make. That's a decision that open source doesn't have to make.
Well, what's great about this is that you don't have, I see what you're saying is that if you're trying to centrally plan this, it's going to be really inefficient. But you actually don't. This is a decision that an individual team member can take. Wow, this problem is so important and it's not getting fixed. Okay? Sort of like cloud computing. It used to be that, hey, I need a place to stage and test my code, I have to go to IT. Well, now I can go to Amazon, I can do it myself. You break a lot of these delays that way by putting power in the hands of the individual. And I think you would agree with what you're saying.
I agree with all the mechanics of what you're talking about are useful, but the basic planning of what is going to be done, if a business says, I need this, this, and this to sell because that's my product vision, then they've got a path that they're planning. This can follow the route that it takes as it unfolds because the user.
Well, business projects have to improvise too. I'm just making a mathematical argument. The worst you can do under this, the worst the slowdown you can get under this is 2 to 1. We know that the slowdowns from big projects are way, way more than 2 to 1 in terms of productivity slowdowns from small projects.
I guess I don't understand the worst you can get is 2 to 1, in that 15 people can decide that they're each going to fix it themselves. Right.
It doesn't work that way. One person will say, yeah, I'm going to fix this. That's what happens. And there's enough communication to make that go. Yeah, we should come back to this because this is an awesome topic. Does anybody want to do another session just on scaling? It's an awesome topic. So I made a statement that both, every time I bring up this mythical man month is wrong, every time I see that, everybody's like, what? You know, and so that's a really good topic. Because it's so right? The book is so right, and yet.
The history is so much different from what you represented.
Okay.
OS 360, at the time when OS 360 was written, I mean, I'm old enough to know what happened then. Before OS 360, there was a system called ran on the IBM 7090 and IBM 7040 and such. It was a fast processing system that used cards, and so and it was relatively speaking, a very slow system. You put your cards in, and you waited hours later before the results came out. The whole concept of computing has completely changed the way you do things. So having small teams and trying to compare what Fred Brooks was writing about in Mythical Man Month, you're correct about the communication environment. You couldn't broadcast everything to 100 people or 1,000 people in that case. So I think that I hear what you're saying, but don't use the Mythical Man Month because I don't think the analogy goes very well.
Well, but the analysis is very specific, communication problem, and I'm saying
communication problem, but there is things that force that communication problem because of the computing equipment around that wasn't available. You had to share one 7090 among hundreds of people sometimes.
Well, this is another good point, which is that there are many reasons why software development is more efficient now. Many, many reasons, and these sorts of methodology questions are just one. And better communication, better tools, just better understanding of what we're doing, global labor pools, right? There are many, many reasons, and that's what's so great about software. I remember back in the early 80s, when I first started looking about it, people said software is fundamentally a labor-intensive business, and productivity never improves in a labor-intensive business. And that's totally not true. And we double our productivity every few years. It's better than what people are doing in semiconductors.
I want to say something. it is so easy to equate Agile with Scrum. Okay, now just was it 2 months ago, okay, we had Ken Schwaber here, and he said, and he's been saying this for years, hey, Scrum isn't the, don't follow Scrum like it's the law. We got to make it better, and he started going on how he wanted to make Scrum better. The kinds of problems that you're talking about can pretty much be attributed to Scrum, and a lot of people who are smart, who really do Scrum well, know that. Okay, but when you do things like add lean and lean thinking to what the business community should be doing, if they're doing Scrum well, they're doing it like lean. It's a lot more like lean than people think it is. You suddenly don't have a lot of these problems. And one example would be what you were just talking about, which is the dependency problem. Lean talks about the dependencies and actually works on reducing dependencies. Okay, Scrum tries to do the same, and in some cases needs improvement to do the same. Its answer to dependencies is do things short. Try to approximate the continuity you get from lean by iterations and making the iterations short. Okay, but it doesn't get you all the way. You have to go beyond the mechanics as described in the mountain goat
slide picture, yeah.
To actually do Scrum well, and people who do Scrum well get away from.
I agree. I think we should come back to this dependency thing. It's a great thing, like in a future thing.
I would just do that as an example for the bigger.
So here's my theory about open source. You were talking about people self-select. Well, actually, that's not true. People have to submit code to prove that they're worthy, and they can get. It used to be that you got selected into the committer team, or you can actually write into the code repository, and you had to be accepted by submitting good code. So in my feeling is the difference is not that people are self-selected. It's that they go through an efficient and very rigorous qualification process, which is essentially trials. You've tried them out. You've tried out their code, and the hiring for an Agile team is a very big, long, high-risk process. It takes a lot of work out of team members and team leaders. I don't do any of this. I just look at what the open source guys do. I put people on trial. I look at their code. And it really streamlines the process. So if you find that you're having this problem, that is a possible solution, possible learning.
But I think that assumes that you're spinning up a brand new team and getting to hire them. In most of the situations I've seen, we've got an existing team, and suddenly we've decided someone pushes them out that we're going to use, Scrum, and we take the existing teams, and there's no interviewing, there's no deciding if you use that.
Okay, well then that's an organizational issue. How are you going to build teams? But there's always options, and the more selective you can be, the better the result you can get.
Sure, if you get to pick better people, you'll tend to have better results.
Okay, well, so I'm just saying there's a couple different ways to do it, and you have to make your organization convince them that that's important, and I think it is.
There are a lot of Agile teams who already do that stuff. This is not Agile. This is historical organizational issue. The method of hiring.
True. All I'm trying to do is pull out some ideas that might be useful, and this is one that really worked for me. Really worked. And it's simple, right? Smallest slide ever.
It also helps that the people that contribute to open source are self-selected. So yes, they're paid by their companies, but they're only going to be contributing if they're interested in contributing. So if they're good or not, that's up to the broader community.
But again, that's an organizational issue that's sort of outside Agile or open source.
Exactly
how motivated are people? But one of the things I would note, I'm going to note this later, that open source teams never talk about how they're going to motivate people. So we'll talk about why that works. So who asked about release planning?
Everybody.
Okay, release planning is really important. And we had a debate about this, so I'm not going to go into who sets the priority, okay? Probably there you can say that, well, the guy that accepts the code is the product owner, so he's going to set the priority. But there are other things that are different, right? When I come to these things, right, we had a session today about estimating. Well, you never hear about estimating in an open source project. You also measure progress against estimates. You're measuring progress in an open source project, but really you're just looking at, do I have something releasable? It's a different kind of measure. You're never going to see a burn down chart. And because you're going to be measuring against your estimates, you spend a lot of effort trying to pick doable tasks for your iteration. In an open source project, you're not making commitments. There's no idea of a commitment. Well, there is. People say they're going to do it. But if you miss the release, you can go in the next release. So there's more room for different kinds of scopes. And I guess that's the point I'm making about sort of, it's like doable tasks, and you try to fix them inside the iteration. There's a lot of pressures that are applied here that can work great, but also cannot fit, right? There's things that don't fit into that thing. And finally, the really big difference that makes all this possible, in open source top project, typically you release when it's ready, whereas the whole goal of Agile is to manage your risk and your budget and visibility, what people see and what people get, by having these timed iterations. And I think actually that's something that I'm not going to advocate that you move away from this. I think this is really valuable. So adapting from open source is going to be getting away from the release when ready.
Companies might say, we want this feature in there, so they may force it inside the company and say, well, we really...
They may force release when ready because of the budgeting process,
right,
which I talked about before. But that's going to be damaging to your Agile process. It's going to lower your credibility, make it harder to release on a cycle the next time because people are going to demand more of those.
No, but that also applies to open source too. But let's say a company wants a feature in the open source. They may say to their developers, please work on this feature because it's important for our product.
Oh, absolutely. And they may, and with open source, it's perfectly fine to say, well, it's not ready. We need to get this in and hold the release.
I understand what I think I have an idea what you're saying when you say no estimates. I actually don't believe you. Talk about the person who's deciding what to do. That person deciding what to do is making estimates.
Yeah, people do make rough estimates. Yeah. They sort of say, what do I think?
What can I do? Can I have it? So part of the notion is you're not doing a storyboard or release points, but you are doing a constant estimate saying, I think I can get this done. This is important. And we can get this done in a reasonable amount of time.
I agree. People are always, in any software development project, they have to be saying, well, this is a reasonable thing to get done or not in this release. They make an estimate at that level. That's sort of a gut level estimate. But since they're not having to do these commitments, it's not as high risk. They don't have to spend as much time on it.
With Agile, if it doesn't get done, it doesn't get put in the release. Doesn't get used in that iteration. Pushed to a later iteration.
Yep, and so I'm about to get to my main point, which is that people who've been working in both processes, Scrum and open source, instinctively make certain adaptations to Scrum. And I'm going to put a label on that in a minute. And you guys will be like, well, that's nothing new because I do that. And that's the point, is that there's instinctive things that people do.
Yeah, I can see, like, when a team or user puts a piece of code in and submits it, they'll have done some module testing already. Carries out the integration testing, systems testing, and acceptance testing. Yes, acceptance would be by the benevolent dictator.
Well, the technical leads or the
who does
maintainers, the guys that are taking the code and saying, okay, I'm going to put this into the build, they do their own testing. So there's several layers of that acceptance. It's literally accepting of code as opposed to features.
So that, to be a benevolent dictator or a maintainer, you'd have to commit to do an awful lot of
You
testing.
spend, that's what you do, is you look, people send you stuff and they say, let's put this in the release and you test it. You make that acceptance. It's literally an acceptance process. So what do I take away from this? Well, sort of a mixture. Do prioritize. Everybody has to do that. You're always working from this backlog. That was one of the things that were the same. Do release on a fixed time cycle. I think that's the sort of the minimum of Agile. We want to be Agile. But I don't invest in estimates. There's a lot of, they're problematic, right? Difficult, wrong, not used. If you're working from a priority stack and always doing the most important thing, the estimate isn't going to change what you do. And that's sort of the biggest criticism I have. And do use code contribution processes, these techniques that open source teams have developed for managing their code in branches and reviewing it. Use that to accept code as you get towards your release. These are like pretty basic things that people instinctively do that are not in the Scrum diagram, okay? So I'm going to call this something slightly different from Scrum. I'm going to call it release-driven development. So it's what people actually do. I'm going to show some examples. And it solves some problems of Scrum that, scalability, it's not a small team process, distributes well, doesn't require estimating, which is extra work, and it allows enough time for planning and design. So one of my biggest criticisms of Scrum is that you do this iteration plan, and there's never enough time. Nobody does it well. There's never enough time to do a good iteration plan. Any kind of planning is really a process that deserves time and should take place through the whole cycle of development. So, I sort of look at that's the exact same diagram, how you get an iteration out differently. Request is the same in a Scrum process and sort of what people really do. I'll call release-driven development. Get your release out. Request a bunch of stuff for this iteration. Build is very similar. People go to that stack and they say, I'm going to work on that, and they pull it off, and then they go through what's essentially a Kanban process. For each task, let's try to move it through to the point where it's releasable. And that's what these Kanban sort of status-based processes are good at, is getting that one task through the pipeline. And that's what opens up space for design and planning. Finally, what people actually do, rather than doing like estimating in burn down to try to hit their iteration, hit their release with exactly what they said, what they really do is they converge. They take anything that's not finished as they get toward the end of the release, and they throw it out, and they stick it in the next release. And then finally, you've been running this Kanban style process. To do a release, you have to stabilize. So you go through a phase where you're just testing and fixing bugs and preparing that release. Here's some pictures from previous presentations. This was Gil from Constant Contact a few months ago. This is an example of converge. He used the word converge. You're feeding tasks in at this end, and at a certain point in the process, you continue to feed tasks, you start throwing them out. And you converge the tasks that you have with the tasks that are done, and then you're ready to release. So that's a really good picture of what people actually do. They don't burn down, they converge. And this is exactly what open source projects do. Here's an example of the stabilization phase. I got this from Google Chrome. They published a description of their development process. You do your Kanban style development. I'm doing tasks, I'm doing tasks, I'm doing tasks. And then you get to the point where you cut a branch that you're going to release. Most of us do this. And you have two choices. One choice is you get all your developers to work on that release. That's sort of the high pressure choice. Guys, you're not going to be able to go back and work on any of that new stuff until this thing is totally ready to release and out the door. So that's the high stakes version. The lower stakes version, which the Google Chrome team went with, is a lot of your developers loop back and they start working on the next release, and you have a stabilization team that does things like translation and localization. So these guys get 5 weeks. At the same time that they're working on the next release, N+1 release, these stabilization and translation guys are working on release N. And they put something into the code, something special into the code. When one of these developers stuffs something into Google Chrome, they put in a variable that says turn that feature on or off. And if it fails testing, just turn it off. It goes into the next release. So that's a really great safety valve. So if you do these kinds of things, it's very similar to Scrum, but you less work planning and estimate at the beginning. You're doing more planning inside the iteration. You're converging, not burning down. Because you're essentially accepting code as it's ready, it's not required that you have a small team or any kind of consensus. You can have individuals, big companies. You're running a code contribution process. Makes it a lot more scalable. And the guy that's doing that acceptance, is the tech lead. That's the real leader of these teams. In fact, I was at Google for some other presentation, and the Google guy said, "Well, tech leads make all the decisions at Google." They subscribe pretty strongly to this idea. Versus Kanban, well, it is Kanban, right? Inside the build phase, it is exactly Kanban. But if you have a hard time doing the sort of continual release at any time, then you need this stabilization phase, and you sort of fall back from Kanban into this process. So again, a sort of meeting reality kind of a thing. RDD, makes comparison with TDD, which is where you essentially do your design by writing tests. And I've worked with these TDD teams and been very disappointed, not at the developer productivity, the developers are great, but when you actually take these things to release, as for instance a web application, all sorts of bugs come out. And you're really focusing on the wrong thing with TDD. You're focusing on the developer experience and not on the release, right? There's a lot of things that go into a release.
But it's not one or the other, right? They complement each other.
It's not one or the other. You may say that, hey, in my Kanban process, I'm going to have a write test phase, pretty common, right? And you can get close to a test-driven development.
I'm just curious if you can elaborate what release-driven development would look like. Is that something like acceptance test-driven development, or?
Well, it's similar to. I'm sort of waving my hands because this is a new presentation, right? I'm trying it out with you guys. I haven't made a nice picture, but it's very similar to the sprint, the Scrum diagram, where you would have these 4 phases, and this is exactly the same. So we're making a sprint instead of a plan. We'll just make a request stack for this time around. In the build phase, you're doing a Kanban process: design, build, test, stage, and then convergence and stabilization we looked at. So I should have I'll make a better picture. Anyway, it's a new idea I'm trying out with you guys, but the effect that I want to give you is that, gee, if you've been looking at some of these open source things and then you're doing Scrum, this is what you end up with, and it really does work better.
So let me, if you were to try to apply this to a closed source project, these philosophies.
Well, the Google Chrome is closed source and Constant Contact in my company, which uses this process.
Sure. How do you? I mean, again, we all work in the real world where you want to reward somebody who's doing well and more so than somebody who's not doing well, right? You have to have a carrot to wave in front of somebody to increase their value in the company is or whatnot. How do you articulate that? How successful someone is in that role as the contributor versus somebody who's not?
Well, Steve here was talking about how do you know whether something's done? And my claim is that in this process, it's pretty easy. It's the same as you would do in any other process. At the end, when you get the release, you can look at, well, how much stuff did each developer get into the release? That's going to become pretty clear. And you can also look at how much work was it? Like, did it have high quality or did I have to rework it? Those are 2 really important measures that you really can evaluate developers on a release basis or in multiple releases.
So you have ways to quantify that specifically by looking at your source code analysis, right? You do source code analysis.
I don't, but that's a good idea.
You look at features then that get delivered, or is it kind of a ballpark thing?
I don't. I mean, we do look at how much rework, by sort of on a ticket basis, how much rework did each person cause. And that's a really good indicator. That's why I brought it up. But we don't look at how much did you get in. I mean, it's often pretty obvious, but maybe we miss some stuff just with our intuitive view. It's a good idea.
So is release-driven development your term?
Yeah, it's a term that I made up to try to encapsulate what I think is really going on.
Okay, and so when you say both you and Google do the same process, so it's just from
what you know from like talking to Google? I mean, because I would imagine they would have something that's like formal, and do they call it release-driven development?
Their processes are a lot less formal than you would expect.
Okay.
And they don't call it release-driven development. But, well, this is an example of a pretty formal process, which to me is clearly release-driven development, especially since we already know that it's managed by tech leads, not project owners, product owners.
They do have product owners and program.
Yeah, so, you know, like any, they converge to what other companies do as they get bigger.
Anyway, I've seen release-driven development, the term, in the literature. In fact, it was on a telephone conference call last week somewhere, and it came up in discussion.
Oh, well, that's good, I'll have to look for it. And maybe it means something completely different than what I'm using.
And incidentally, this is different than the open source, so this is a shift in the talk, right? It's not
Right,
the
and
same
the whole idea of this was what can you learn from, what does open source do, and then what can you pull out of that? And the point that I'm making with this release-driven development is that there's sort of an attractor, right, in dynamic theory of, if you're doing Scrum and you're familiar with how open source projects work, you drift into this kind of process, or you formalize it in a big scale, the way the guys at Constant Contact did. I'm not going to go on, I had more, but we're at the end of our time, and that was the meat of it. Did everybody learn something?